Estimate and compare quantities. Learning goal: estimate and compare very large and very small quantities using powers of 10 or scientific notation. Estimating powers of 10. Step 1. Convert the quantities to scientific notation. So if we have the number here, 346,500,000, we're going to convert that to scientific notation. So we're going to move the decimal point that would otherwise be at the very end of the number, and we're going to move it 1, 2, 3, 4, 5, 6, 7, 8 spaces. Or you can count the numbers or digits before the 3 and then write it as a coefficient 3.465 times 10 to the power of 8. Step 2. Round the coefficient to the nearest ones. So the ones is place value where the 3 is. Look at the digit in the 10th place. So look at the digit here, which is the 4. If the digit is 5 or greater, increase your 1's value by 1. If the digit 4 or less, then keep the current 1's value. So because this is 4 or less, we're going to keep the 3. So to rewrite it, we're going to write 3 times 10 to the power of 8. So it's approximately that. Comparing powers of 10. So step 1, to express how many times one quantity is larger than the other, calculate the ratio of the estimated numbers in scientific notation. So your first step will always be to figure out what the estimate is, which is what we did here, of a quantity that is given. Or it might be given to us in scientific notation, but we would then find the approximate value by approximating the coefficient to the 1's value. So step 2, divide the larger number by the smaller number. So if we want to find the ratio of the larger, divide by the smaller. So if we have an example here, 3 times 10 to the power of 6 divided by 2 times 10 to the power of 5. We know this is the smaller number because the exponent is less than the exponent above. So this one is 6, therefore it's higher, it's a bigger number. So we're going to divide the coefficients. So 3 divided by 2 is 1.5 times the base 10 and 6 minus 5 of the exponents. So 6 minus 5, because the base is the same, we subtract the exponents, is 10 to the power of 1. Step 3, convert the number to standard form. Round your answer to the nearest first or second digit number. So the example here, 1.5 times 10 to the power of 1, we're going to convert it to standard form, which is 15. Therefore, 3 times 10 to the power of 6 is 15 times larger than 2 times 10 to the power of 5. We're going to answer some examples and questions. Estimate and or compare quantities using scientific notation. Question 1. In 2023, the population of the United States was about 334.9 million people. Express the estimate of the population in scientific notation. So I'm going to first rewrite this number in standard form. 334,900,000. And there is a decimal point here that would need to be moved 1, 2, 3, 4, 5, 6, 7, 8 times, 8 places. Therefore, in scientific notation, it is 3.349 times 10 to the power of 8. And now to estimate this, we're going to look at the 3. So the value in the 10th place, and it is less than 4. So we're going to round the 3, keep it as it is. So it's 3 times 10 to the power of 8. Question 2. The size of a water molecule is 0.0000000000275 meters. Express the estimate size of the molecule in scientific notation. So we're going to move the decimal point from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. Or you can count the numbers of zeros. And we're going to rewrite it in scientific notation, which would be 2.75 times 10 to the power of negative 10. We're going to look at the value in the 10th place, which is 7, which means we're going to round the 2 to one value higher, which would be approximately 3. Times 10 to the power of negative 10. Question 3. The world population in 2023 was about 8.025 billion. Approximately how many times larger was the world population compared to the population of the United States? Use the info provided in question 2, because we will be comparing the population of the world compared to the population of the United States. So first I'm going to rewrite 8.025 billion in standard form. So that's a million, and this would be billion. So 8.025 billion in standard form is this, and then in scientific notation, it is 8.025 times 10 to the power of 9, which is approximately, if I'm going to round to the nearest ones, the number to the right is 0, so I'm going to keep the value of 8. Therefore, it's 8 times 10 to the power of 9. So now step 2, I'm going to divide the larger number by the smaller number. So 8 times 10 to the power of 9 divided by 3 times 10 to the power of 8. 8 divided by 3 is 2.6 repeating, times 10 to the power of 9 minus 8, as we subtract the exponents because there's division and the base is the same, which equals 2.6 times 10 to the power of 1. I'm going to convert it to standard form, which is 6 point repeating 6. And now I'm going to write the approximation. I'm going to round it to the nearest tens. So I look at the number to the right of it, which is 6. It's higher than 5. Therefore, it is about approximately 30 times larger. So therefore, the world population is about 30 times larger, or approximately 30 larger.